Hey scholars, welcome to chapter 18.3, looking at acid deposition and aka acid rain really, and what is the problem with that, and what are some causes, and what are the problems that are associated with those. So we're taking a look at acid deposition today. We know it as acid rain. That's what you probably we call it acid deposition because it can come down in many forms. It can come down as a solid or a liquid, so we call it deposition as it being deposited from the atmosphere. Today we're going to look at the formation of how it actually is formed and created. And we'll look at local versus regional problems. We'll give some examples or case studies on that too. And then we'll look at how prevailing winds can actually help disperse that or move that acid rain to different locations, causing them to be more regional problems. Also looking at what are some of the methods of cleanup using buffers or limestone, and how maybe that some areas aren't nearly as impacted as much because it has a good limestone base in its soil. And then we'll also look at where is the worst acid deposition found in the country. So let's first talk about how it's formed. When we look at it, again, it's mostly coming from, again, man-made sources, looking at sulfur dioxide and nitric oxide in the atmosphere being produced by power plants, and that can go up in the atmosphere. It can change to then transform into sulfuric acid or nitric acid, where then that's what it combines with the water vapor, and then that can be either can be deposited or it can stay as an acid fog, which is can cause some major health problems as far as respiratory problems, or it can move by wind or just rain down back onto the area that it was produced. But most of the time, because of the prevailing winds or the movement of the atmosphere, the winds take those nitric acid or that H2SO4 and HNO3 across or in a different direction, and then deposit it somewhere completely different. So the people who are creating the acid deposition or the acid rain components aren't even the ones being affected by it. That can be somewhere else further away. Here are some of the major areas of the current and possible future acid rain problem areas. The sad thing about this is that acid rain has caused a number of damage to a number of different natural areas, as well as man-made creations like statues and some very, very old statues and buildings. And if you look at the areas that are current problems, that's all over the Northeast, which is kind of where we settled and where some major historic places are, as well as in Europe, which is made up of a lot of history as well, and England as well. So all this area, we have lots of rich history and culture behind our statues and buildings made of some of those more basic rock types are having some major deterioration because of acid rain, and you can see over in China as well. So those are some of the areas that are definitely current problems, as well as could be possible problems in the future. And this is just an image of what acid rain can do as far as deteriorate some of those statues. You can see the deterioration around the arm and the face, and it's just kind of sad because those are have been around for a long time and will probably never be created, at least in that detail again. So let's take a look at the number of harmful effects. Number one, it has caused problems with human respiratory system, which we saw last chapter when we looked at human health effects. Aquatic ecosystems can be affected. It can change the pH of an aquatic ecosystem, which could drive out and kill populations of aquatic organisms, or it can cause some just change in the whole dynamic of the ecosystem. It also can release toxic metals and also leaches out soil nutrients, which are vital to plant survival. And all that will lead us to lose crops and also trees in the forest, depending on where that acid rain is being deposited. And also damage to buildings and statues and monuments, like we just talked about. This is kind of how it's very, very damaging to trees and crops. I know maybe the myth is that when acid rain comes down, it'll burn your skin. Not really. That's what a lot of people think, but it's really not how it works. The most damage comes from the leaching of soil nutrients, and that really causes those plants to die. So even though the plant might look dead or lost of leaves and you think the acid ate those away, not necessarily. Most time it comes from the leaching of those nutrients. So as the acid rain comes down, it can have some direct damage to leaves and bark, but I think it more has an effect on the leaching of soil nutrients. It also pulls out some of the toxic metals that are held in the soil and then allows them to go down to your water system, your groundwater, or your lakes, which can cause problems with aquatic habitats. But because that leaching, all these things will damage the roots, and when the roots die, then you're not getting any leaves, not going to be producing leaves, and the tree will die and it'll look very bare. So most of it, you might see some damage, like little spots, little white spots on leaves, or things like that that are having being caused by acid rain, but not necessarily the whole tree losing its leaves. Most of that is either because the tree died because it doesn't have enough nutrients, or because it doesn't have enough nutrients, it's also susceptible to drought, extreme cold, insects, and parasites, and then it dies that way. So it could be a combination of killers for your trees or crops. Let's take a look at a science focus section, a little core case study. Hubbard Brook, we studied this actually in chapter 2, we're looking at positive feedback loops. I'm bringing that topic up again because that comes up on the AP exam a lot. So when we look at positive feedback loops, we looked at a study like this where they actually cut down the trees along the banks of a river and saw what kind of damage that did to the whole ecosystem as a whole. And that was happening in White Mountains, New Hampshire. And so when we take a look at this, what they did with this is this is a high area of acid rain on the forest, and they did some experimentation to kind of see what effects those had and really dived into what was the root cause of the tree death. So trees not really suffer from direct contact with acid rain, so in that case you couldn't even see the little spots on them or any sort of negative effects from that acid rain, but the nutrients they found that were leached out of the soil, which caused an effect of calcium on regrowth trees. So a lot of those calcium, magnesium, the things that are used in tree growth take decades to restore in soils. And once they were leached out because of that acid rain, the trees didn't have enough of the nutrients that it need, and so then those ended up dying off. So that's one of the science focus sections there. All right, so let's take a look at how we reduce acid deposition. First of all, the prevention approach is always the best approach and always the cheapest. So our biggest one is to reduce the use of coal. If we can reduce the use of coal or filter out some of the air pollutants that have that sulfur and have that nitrates in them, then that would be key. That would be our prevention approach. Our cleanup, though, there's a couple of ways you can do it. One of them is that some of these areas aren't nearly as impacted as others because a lot of times what happens is lime or limestone. A lot of times if a soil or a base, if the soil has a lot of limestone in it, rocks and things like that, then the land itself has already kind of a basic pH. So if a little bit of acid isn't going to nearly affect it, is an area that does not have any limestone at all underneath the soil. So one thing to do is you could add lime, which is a base, to neutralize, maybe you remember this, the neutralization reaction that titration labs used to do in chemistry, and add that lime to neutralize the acidification on lakes and soil. That way you're not having the leaching out of the soil nutrients so those plants can still thrive. Another way is to add phosphate fertilizer to neutralize acidified lakes or soils. And I think it would maybe work better for soils to help trees with their growth. But if you add phosphates to an aquatic ecosystem, remember, it can lead to cultural eutrophication, but it is one way of at least maintaining somewhat of a balance for those acidified lakes. So there's your prevention: reduce coal, burn low sulfur coal, increase natural gas use, which is cleaner as far as nitrates and sulfurs. Increase the use of renewable energy, remove sulfur dioxide particles and nitric oxide particles from smokestack gases, remove it from motor vehicle exhaust, and tax emissions of sulfur dioxide to help with to lower the amount of acid rain in the atmosphere and also kind of come in contact with the earth. Clean up: add lime to neutralize acidified lakes, and add phosphates to fertilize to neutralize acidified lakes as well. That brings us to the end of our section on acid deposition. We'll see you guys next time for indoor air pollutants.